Let's talk about aliasing and why that might be important for lists. So an alias is another name for something. Say my name is Jacob and some people call me Doug or something, then Doug is an alias for Jacob. For lists, we can make aliases. So we can create a list A, and an alias for A could be B. Why are we bringing up this new term? We've already seen where we can assign something to something else. Because with lists, because they're mutable, there's some things that are going on here. So you might think that we have a copy of list A, and we called it B. So let's change something from B. Let's change one of the elements of B to the char Z, the element 2, or element at index 2. If we print both A and B, we would expect to see that B now has this change. We wouldn't necessarily expect A to be changed. But we see here that both A and B are different, or that they both received this change. Why is this important? Because when we make an alias, we're basically saying that B is another name for A, or B is this list, but it's another name for it. This is important because when we run into functions, and you'll see this in a minute, when we create a function and we have a list in there, and we say, so let's say we make some change to the list. When we actually call this function on our list, we are going to be changing that original list. Okay, so let's print this. So when this aliasing thing is happening, it's very important for function calls, because this term here, this generic term, which is in the function, this is an alias for this list here. So when this goes into the function through the function call, we're actually changing the original list. And that is something that is happening with lists, because lists are mutable, and this aliasing is important to keep track of, or else there will be you'll run into different issues where you don't know what's going on or why your list is changing. So it's important. We'll do another example of this in a bit. But what's key to note is that when you assign a list, so when we assign A to B, we're not copying the list. We're not making a separate copy. We are just creating another name for the same list, aka aliasing. If we wanted to copy the list instead of this aliasing thing, we could do slicing. We could use slicing. So if we have a list, instead of saying B equals A, which would be an alias for A, we could make an actual copy where we are taking a slice, and this colon just means we're taking the entire list. We've seen this in the previous video, where we slice from one index to another, but this notation just means we're taking the whole list. So this command right here is copying the list A, and it's making a separate copy. So let's try changing B. Let's say B2 equals Z like before, and we'll print A, and we'll print B. So we see that this list A is still the original, and B is a separate copy that's been modified. Okay, so this is a way to copy that list, and if we wanted to create an alias, we would do this. Let's get into how to loop through a list. We've already seen in the previous video we can say for I in list. We have to define a list, and we can do something here. We can say print I, or we can do something else, but if we run this, we're going to print each element of the list. So we're saying for each element in the list, do something. In this case, print I. There are other ways to loop through it, though. We can say for I in range length of list. So recall, what does length mean? It's just how many elements are in the list. So in this case, 3. So for I in range 3 means we're starting at I equals 0, then I equals 1, then I equals 2, and we're stopping there. So we can print I again. So we see that we start at 0, then go to 1, then go to 2, and we don't reach I equals 3, which is the length of the list. We stop at the 2. Another way that's very useful to loop through a list is enumerate. Why is enumerate useful? You might see in your assignment that you might need to look at the index of a list, and also you might need to keep track of the values. So enumerate lets you look at both. Let's say we have a list with values 1, 2, and 3. What is enumerate doing? It's taking our list, and for each element, or for each index, it's printing both the index and the value. So enumerate takes the list, and it gives you the index, and it gives you the corresponding value for that index. If we print I here, this is called a tuple. We won't get too much into that, but the point is that enumerate allows us to print the index and the corresponding value. It might be confusing with the numbers, so let's just say car, dog, and cat are our list entries. So enumerate, what's doing, it's printing out the index and also the value. Way to access these individual parts, these components, let's say we want to get the index only. There you go. If we want both the index and the corresponding value, we can print I0 and I1. Okay, there's no I2. There are two components. There's an index component and a value component. Getting back into aliasing and how it's useful, or how it's useful to know when we're dealing with lists. Let's look at this other function. So this function is called double, and it doubles each of the list entries. Okay, what is it doing? We're saying for I in range length of list. So we're starting with I equals 0. We're going all the way to however long the list is. Say the list is 5, then we'll go I equals 0, 1, 2, 3, 4, and then we're done. And let's say I equals 0 in the first iteration, then what we're saying is list 0, so the first or the 0th element of the list, is going to be equal to 2 times itself. So we're doubling for each list element, we're doubling it. Let's create a list. And we'll call the double function on my list. We'll print it, and we'll see what happens. So, why is aliasing important here? So to review what we talked about previously, with just another example, what is aliasing doing to lists? Well, the alias for this list is this generic parameter. When we call the function with mylist, we are putting that in for a placeholder, for this list placeholder, and we are changing my list by saying mylist I equals 2 times mylist I. And so we are making changes to the original list using this function. What is it called when we have a function that does this, that makes changes to our original parameters? This is called a modifier. Okay, I think I have it here. Yeah, so this function which makes changes is called a modifier, and the resulting changes it makes, these are called side effects. So let's run this, and we see that it doubles the original list entries. Getting practical, let's say for your assignment, where is this going to be useful to know? Well, in your assignment you do something, you make some population of people, you have some function that creates a population for you, and let's say you have 15 people in your population. That generates a list, okay, and this list is going to be used as an argument in certain functions. Make sure you notice that when you are passing this as an argument and you make changes in your function, you're actually changing the original list. So this is one example of many, and you'll run into many as you program more. It's important, and I keep talking about it because I've made lots of mistakes with this and I've been punished for it. So keep track of your functions, and especially those which are modifiers and those that create side effects. Functions that don't have side effects are called pure functions. Just another term. Let's finish by talking about how to nest lists and what we can do with these. Let's say list A equals ABC. We'll say list B equals 1, 2, 3. Okay, so we have two lists. We can actually put a list or nest a list inside of another list. So we can say list A dot append list B. So this it's not like concatenation. We're not saying that we have ABC 1, 2, 3. We're actually putting this list as an element. We're adding this list to the end of list A as an element. So when we print list A, we see that we have our list elements. We have A, B, C, but what we've appended is another list. Okay, so this is nesting of lists. And we can keep going if we want, however many times. Let's say list C is dog, cat. Okay, we can add list C to list B. So that will put this dog cat list, it will add it to the end of list B as a new element. And then when we add list B to the end of list A, we'll have a list inside of a list inside of a list, which, you know, it will get more and more confusing and complicated as we keep nesting, just like with loops. So we can print this list and see what I'm talking about. So we have ABC, right, from list A. This is list B, which we appended to list A, and list B, which is this list right here, has a list as one of its elements, which is list C. So list C is in list B, which is in list A. Okay, so this is an intro to nested lists, and you'll see nested lists in your assignment. So it's good to get used to these things, and we'll definitely be seeing more of them. But if you have any questions about this, nested lists, or anything else I talked about in the video, or anything at all, just feel free to email me whenever. I can do a Zoom call. Just give me a time that you're free and we can work out a time together. If not me, then reach out to one of your TAs or reach out to the other students through the forums. And for next week, no reading of the textbook, just take a look at this NumPy tutorial. Just skim it. That's it for this week. Hope everyone has a good week, and take care.